Welcome everyone, my name is Matt, and today we'll be continuing development on our Elder Scrolls Online add-on called SimpleClock. In the last video, we made this add-on to show the weekday, date, and time in hours, minutes, and seconds in-game that updates every second. As a bonus, we added a show clock and a hide clock command to give the user a bit more control. In this video, we're going to give the user even more control by providing settings for our add-on. In the settings, we'll add an option to turn on and off the visibility of the clock and give the player the ability to change the font size, and color of the text. To do this, we'll need to use the ESO built-in functionality called SavedVariables. In the last video, I mentioned that ESO has very strict input-output functions available to add-on developers. Using SavedVariables is the only option to persist data related to your add-on. Essentially, when you use a saved variable, a value is saved to a file when the UI is reloaded through the reload UI command or when the user logs out. The variables are read when the user logs in or the UI is reloaded. These saved variable files are located in the saved variables directory at the same level where the parent add-on folder is on your installation of ESO. Most add-on developers use saved variables, so if you've installed add-ons before, there's probably many files in this directory already. Let's remember this as we dive back into the code. The first thing we have to do is add settings for our add-on, so the user can access the options. To do this, we'll need a dependency called LibAddonMenu. LibAddonMenu is an add-on available for download from your add-on manager, such as Minion, or available for manual download at ESOUI.com. We need this add-on because it provides the functions to quickly and easily create options for a specific plugin. To tell SimpleClock that we now have another add-on providing us functions, and is thus a dependency, we have to add the following line to our manifest. #, space, depends on, space, LibAddonMenu -2.0. Now, we can hop back into SimpleClock.lua and start setting up how we want to interact with LibAddonMenu. I'd like to preface here with the fact that I'm still actively learning how to program add-ons. So I'd like to say in the last video, I showed how to initialize the clock method in SimpleClock.onAddonLoaded. Because of the way we're calling this method, through register for event and the event add-on loaded event, this function will be called every time an add-on is loaded. We didn't pick that up last time because nothing conflicted if we registered SimpleClock more than once. However, LibAddonMenu will complain that we are creating options that already exist if we leave it how it is. To avoid this, we have to first add the event and name arguments to SimpleClock.onAddonLoaded. And if name equals, and in quotes, SimpleClock, then return end. The equals is the Lua syntax for not equals. Essentially, if the name of the add-on is not SimpleClock, then we eject out of the function and we do not do more work. If it is, we continue on to clock. We could leave it there, but we could also unregister for the event by writing event_manager : unregister for event, and we pass it two arguments, SimpleClock in quotations, and event_add_on_loaded. This will unregister SimpleClock from listening to the event_add_on_loaded events from other add-ons because now we know SimpleClock has loaded. Let's create a new function called initialize SimpleClock add-on. This function will do all of the necessary setup for the options pane, as well as load in our variables from the saved variables file that I mentioned before. Let's first set up the options pane. LibAddonMenu does an excellent job at making this as simple as possible. First, let's initialize a local variable called LAM and set it to the global variable LibAddonMenu2. This is a global variable provided by the LibAddonMenu add-on, and we can access it by just saying LibAddonMenu2, the same as the ESO provided event manager or _g variables as we discussed last video. Let's create another local variable called panel name. This must be a unique string, as it is used to identify the page the settings will go on in-game. Let's set it to SimpleClock options. Let's make another local variable called panel data, which will contain the data visible to the user. Make it a table and set the type to panel, the name to SimpleClock, and I'll set the author to @Moshulu to let the player know that that's my in-game name. There are many more options that you could provide to the panel data variable shown in this table, but I won't add any more at the moment. Finally, let's create one last local variable called options data and make it an empty table. This table will contain all of the options available to the user and how programmatically we have to manipulate our data. Let's add this panel to the game by creating another local variable called panel and using the LibAddon method register addon panel by writing LAM : register addon panel and pass panel name and panel data. This function is documented in the LibAddon method wiki and in their tutorials as how to create an options panel. We've passed our unique panel name, SimpleClock options, and the panel data, which will show the name of the plugin in the settings as well as the author name as a panel. We also have to add option controls to the panel for our panel to actually do something. Let's use the LibAddonMenu method register option controls and pass our unique panel name and the empty table that we created before called options data. Finally, we're ready to reload the UI and test to see if our options panel is working for SimpleClock. Everything looks good to go. As you can see, the name option in the panel data sets the name of the settings tab, and our name goes right underneath it. Pretty cool. But the player can't exactly do anything right now. So let's change that by taking a step back and thinking about what is the goal of this update to SimpleClock. I want to update the visibility, the font size, and the font color. Visibility is just an on-off, so the data type would be a Boolean. ESO provides only a few fonts, so it could be good if the user could select what they want in a dropdown. We'd probably store the font names as strings. There's far more sizes that a font could be, so maybe that would be good as a slider. And then we'd store the font size that the user picks as an integer. And finally, we're going to need some sort of color picker so that the user could really customize how their clock looks. ESO stores their colors in RGBA, so this one's going to be a bit trickier to store. To give us greater verbosity, let's store the color as a table with an R, G, B, and A value as integers. Now that we have an idea on how we're going to store this data, let's actually create it. At the top of our code, let's write local saved variables. This will be the variable that is visible to all of the functions that we've written and will write that stores the saved variables that we have read from the SavedVariables file. In SimpleClock.onAddonLoaded, let's write SavedVariables equals ZO underscore SavedVars new account wide and pass in quotes SimpleClock vars, 1, nil, spelled NIL, defaults. Now there's a lot going on here. This is an ESO provided function that creates, if it doesn't already exist, reads from, and reads to a specified saved variables file. The first argument, SimpleClock vars, is another unique variable that tells the add-on which saved variables file to create, read from, or write to. The second argument is the saved variables version. Now this isn't as important right now, but if a saved variables file exists with, say, version 1, and I increment the version number, the saved variables file will be overwritten with new values. This is useful for updates to the structure of your saved variables, or to overwrite them entirely if you made a mistake, but not really important for this tutorial. The third argument, nil, is an optional argument to be used to separate other saved variables using the same table. Providing a string here would create a subtable in the saved variables global table. You could use any string here, but if nil is passed, the global saved variables table of our add-on will be named default. Finally, the last argument expects a table of default values. We've said our table is named defaults, but we haven't created it yet. Let's do that now by writing local defaults equals, and in curly braces, visible equals true, comma, font equals, and in quotations, gamepad underscore light underscore font, comma, font size equals 24, comma, font color equals, and in curly braces, R equals 255, G equals 255, B equals 255, and A equals 255. These are the exact same data types that we decided on just before with the same structure. We'll explain more fonts and more font sizes later, but for now, just trust me that these are good default values. Finally, we must add a reference to our saved variables to be read into our manifest. Let's go to our manifest and type #, space, saved variables, colon, space, SimpleClock vars. This must be the same value that is passed in the first argument of zo underscore saved vars, colon, new account wide. Let's reload the UI. Nothing has changed in game, but if we go to the saved variables folder that I mentioned before, you'll see simpleclock.lua. Let's open that up. As you can see, a Lua table has been created with our default values. As we manipulate the options in-game, the values in this table will be written to this file when we reload the UI or log out, and read from this file when we reload the UI or log in. The SimpleClock vars value is actually the name of the global table as well, and we have to be careful that it doesn't pollute the global namespace, meaning if you name it something common, you could get unintended results or conflicting add-on saved variable tables. Since we use the new account wide function to create these variables, the variables will be active for the add-on regardless of the character that you're playing on, but that does not have to be the case. There are ways to filter the character that you're playing on to have specific saved variables, ways to filter the server that you're playing on, and much more. I will not get into that this video, but if there's some interest, I'll look into making something in the future. Let's head on back to our Lua code, and let's take a second to take stock of what we've done. We've created a panel to store our options, we have a plan on what we want to manipulate, and we've created saved variables with default values. That's a great foundation for creating our options and writing code to manipulate the clock in-game and save the options to saved variables table. Let's create these options one at a time, and first start by creating the visibility option. LibAddonMenu says that the syntax of the options data table must contain an integer keyed subtable. The syntax of that looks like this. Start square bracket 1 end square bracket equals and an empty table. These subtables have specific options that we must pass in order to get the result we require. The documentation is available here. Since our visibility option is a Boolean, we just need to turn it on or off, meaning that a checkbox type would be best. Let's look at the documentation. We'll need to specify the type, name, getFunc, setFunc, and perhaps we'll set the tooltip as well. Back in our code, let's add type equals checkbox, name equals visible, tooltip equals shows or hides the clock, getFunc equals function, start parentheses, end parentheses, space, return, space, end, and setFunc equals function, and in parentheses, value, end. Now, go back to the game and reload the UI. Navigate to our options panel, and voila! We can now see a visible option that allows us to switch on and off something. It doesn't actually do anything yet because we haven't provided the getFunc or setFunc functionality. Let's do that now by adding getVisibility to the getFunc option and setVisibility value to the setFunc option. getFunc is fired only when the panel is initialized. setFunc is fired only when you're manipulating the options in the panel. LibAddonMenu automatically sets the passed argument in the setFunc to whenever you manipulate that option. Let's write getVisibility by creating a local function called getVisibility above initialize SimpleClock add-on that simply returns the SavedVariables.visible variable. Then we can create a local function called setVisibility that's passed an argument called v. Then let's see if v is true by writing if, and in parentheses, v equals true, and then outside the parentheses, then, and below that, show clock. Else, on the next line, hide clock. And remember to end this block with the end keyword. Remember, v is the value when the user interacts with the visible option on our panel. If they switch it to on, v will be true, which means we have to show our clock. Else, we have to hide our clock. We're doing it here by using the functions that we wrote in the last video. There's one last thing that we have to do, though. We have to set the saved variables table to our new value. Since we wrote some commands that use showClock and hideClock last video, let's set the saved variable.visibility value in the showClock and hideClock functions. In showClock, write SavedVariables.visible equals true. And in the hideClock function, write SavedVariables.visible equals false. This way, the saved variables will be set if we only use the slash commands that we wrote in the last video as well. One last thing. When we first load up the add-on, we have to set the default visibility value as well. Let's do that by going to the very top of the initialize SimpleClock add-on and using setVisibility, let's pass the SavedVariables.visible value. Remember, this will hold the red value from our saved variables file when we reload the UI or log in. We're all set to go back to the game, reload the UI, and test our visibility functionality. It looks like it's working, but are our saved variables working? Let's see. Let's turn off the visibility and reload the UI. We're expecting to not see the clock. Okay, we can't see the clock. Let's check the options. It still says visible off. That's great news. It means it's working. Let's turn the visibility back on. Congratulations. This may seem small, but this is actually a huge step in your add-on development journey. Saved variables are extremely important for customization and ease of use, and allows us to do some extremely powerful things. Let's tackle the next option, fonts. In our options data table, add square bracket 2 equals and an empty table, and in that table, let's add a dropdown. Reading the documentation, let's put in the type, name, tooltip, choices to set what the player could choose, getFunc, and setFunc. Let's add type equals dropdown, name equals font, tooltip equals the font of the clock, choices as an empty table for now, getFunc equals function, start parentheses, end parentheses, return, space, getFont, start parentheses, end parentheses, space, end, getFunc equals function, start parentheses, end parentheses, return, getFont, end, and setFunc as function, start parentheses, value, end parentheses, setFont, start parentheses, value, end parentheses, and the end keyword. To fill in the choices table, we need to understand what available fonts are from ESO. Let's head on over to wiki.esoui.com and under the GUI section, select Fonts. This page is out of date, but contains some important information on how to gather the most up-to-date information about the game's provided fonts by default. It says, ESO currently uses 9 core fonts from 8 OTF files. It then creates unique versions of these fonts by assigning various text formatting properties. Looking below in the font names, we could see these unique versions of the fonts. They're defining a font tag with the name ZO font win H1 with the font bold font bar KB underscore 30 bar soft dash shadow dash thick. ZeniMax does this for convenience so that they can reference ZO font win H1 for something with a bold font, size 30, and a soft shadow thick style. We don't want this. We want the player to decide each of these options. So, working backwards, what is this variable, bold font? Well, they're defined in default font strings underscore western.xml and above in the core font section. As you can see, the string tag with the name bold font has a value of this OTF file, which holds the definition of the font. There's 9 OTF files, as the description said. These are our fonts, and we can reference them by using these defined names. You can also look at the most updated version by looking at ZeniMax's GitHub repository, since this wiki page is outdated. The tags that define font sizes are also defined here, but we'll get into that in a second. Let's add the fonts to our dropdown in the choices table. This table doesn't have any keys, it's just a list of strings. We have medium font, bold font, chat font, gamepad light font, gamepad bold font, antique font, handwritten font, and stone tablet font. To add functionality to our dropdown, let's define the getFunc with the getFont function and the setFunc as setFont, and pass the value argument to the function. Then, create the local functions as we did previously. The getFont function will return SavedVariables.font, and the setFont function will set the SavedVariables.font variable to the passed value, which is font, and actually set the font in-game. To do this, we must use the setFont function on the SimpleClock label, much like we did in the previous video with setHidden. The argument to setFont is a string, with the formatted barred font string that we just saw in the wiki. The syntax for that is the font name, bar, font size, bar, and then the font style. It's easy enough to format this string. It'll be quote, $, star parentheses, quote, dot dot, font, dot dot, quote, end parentheses, bar, $, star parentheses, KB underscore, quote, dot dot, get font size, dot dot, quote, end parentheses, bar, soft dash shadow dash thick. A few things to note here. The dot dot operator is Lua's way of concatenating strings. We're dynamically setting the font variable using the $sign notation in parentheses to get ZeniMax's font file. Finally, we don't have get font size. ZeniMax sets the font size and the font itself at the same time, so we must do it at the same time as well. Before we write the option for font size in our panel, let's write a temporary getFontSize function so that we can test our setFont functionality. In getFontSize, just return an integer. I know 24 is a good font size, so I'm going to return 24. Remember to set the font in initialize SimpleClock add-on by writing setFont, SavedVariables.font, just like we did for setVisibility. Last, let's remove the font value in our XML file. If we leave it there, it'll override anything that we set in our Lua script. We'll just set it to font equals empty string. We're setting this value in our script via the ESO provided setFont function. Save, hop into the game, and reload the UI. Go to Settings, and let's change the font. Looks like it's working like a charm. We're on a roll. Let's start making the font size option in the option data table. The type will be slider, name as font size, tooltip as the font size of the clock, getFunc would be function, return, getFontSize, end. The setFunc would be function, value, setFontSize, value, end. And we have two new keys that will be very important to us, a min and a max. They're the minimum value that the slider will be and the maximum value the slider will be. To determine what these values should be, let's head on over to wiki.esoui.com, fonts page, and let's see what the available sizes are. It looks like according to this list, we can see that the font size has a low as 8 and a high as 54, but there are some gaps between the numbers. After doing some testing, I know that 40 is very big, so let's set the maximum value to 40. As a side note, we're using the KB list, which stands for keyboard, because the GP list, which stands for gamepad, is for the console version of ESO. We can safely ignore that. Let's go back to the code and set the min to 8 and the max to 40. In our getFontSize that we defined before, let's alter 24 to SavedVariables.fontSize. Great. We also need to create a local function called setFontSize. This is going to be a bit trickier, so bear with me. In order not to mangle the original passed value, let's set a local variable called value equal to v. The slider will not work if we try to set the font size to an invalid value. Remember when I said that there are some gaps available in the font sizes? We have to account for that now. Let's look at it a bit closer. It seems that in between 8 and 40, there's 27, 29, 31, 33, 35, 37, 38, and 39 missing. I think it would be a good idea if the player sets the font size to any of these numbers in the slider we could change it to a valid font size that's close to what they've chosen. For example, if the player chose 27, we could set the font size to 26. If the player chose 35, we could set the font size to 34. That way, we would create the illusion that all numbers between 8 and 40 are valid. There are a number of ways to do this, but I would prefer, from a readability standpoint, to use Lua's version of a switch statement. Let's create a local variable called case as a table. Then let's set the index to an integer, where it's equal to each of the invalid values. The first one would be 27. The value of index 27 will be a function, where we set the value of our variable value to 26, which is a valid font size. Remember to end our function with the end keyword. Let's do this for the other invalid font sizes as well. 29 would become 28, 31 to 30, 33 to 32, 35 to 34, 37 to 36, 38 to 36, 39 to 40. To actually use this table, we must also add if space case in square brackets value, then case in square brackets value, and outside the square brackets start parentheses and parentheses, and add the end keyword. This if statement will check to see if the originally passed value exists in our case table, then executes the function provided as the value of the key in our case table, which updates the contents of the value to a valid font size. Finally, we can set the font size the same way that we set the font before. Let's write SimpleClock label, set font, quote, $, start parentheses, quote, SavedVariables.font, quote, end parentheses, bar, $, start parentheses, KB underscore, quote, value, quote, end parentheses, bar, soft, shadow, thick, quote. This uses the value variable that we were just working with to set the font size, and uses the SavedVariables.font value to set the font. Remember, these two options go hand in hand. The last thing we have to do, of course, is update the SavedVariables.font size value to the valid value that we just determined. Remember to set the font size in Initialize SimpleClock add-on when we log in. Let's go back into the game and check our work. Everything seems to be working swimmingly. We can see the font size be affected every time we move the slider, and we can see that when we change the font size stays the same. Let's tackle our last option, setting the color. In the options data table, let's add one more entry. The type will be colorpicker. The name will be font color. The tooltip will be the color of the font of the clock. The getFunc will be function, return, getFontColor, end, and the setFunc will be function R, G, B, A, setFontColor, R, G, B, A, end. Note that the color picker has 4 separate values that we need to handle instead of the one that we have been doing. In getFontColor, we're also going to need to return 4 separate values. Remember the default table that we made before? We set up to handle the font color as a subtable. So in getFontColor, we're going to return SavedVariables.fontColor.r, SavedVariables.fontColor.g, SavedVariables.fontColor.b, and SavedVariables.fontColor.a. In setFontColor, we need to handle the arguments passed through. And let's immediately use the ESO provided function setColor, RGBA, on our SimpleClock label. Then we have to save the newly set RGBA values to our table, just like the other options. Let's write SavedVariables.fontColor.r equals R, SavedVariables.fontColor.g equals G, SavedVariables.fontColor.b equals B, and SavedVariables.fontColor.a equals A. Remember, let's set the font color to our values in our SavedVariables table when we load into the game by adding setFontColor to initialize SimpleClock Addon. Let's hop into the game, reload the UI, go to your settings, and play around with the color of your clock. Excellent. Let's set it to red for fun. Now let's reload the UI and we'll see that the color continues to be red. Everything is working perfectly. We've covered a lot of ground in this video, but all of it works in tandem to produce readable, maintainable, and working code so that the player may have a good user experience with your add-on. We've went over saved variables, an integral piece of add-on development, and integrating libraries into your add-on to provide custom options, which is invaluable. You do not want to reinvent the wheel. Thank you so much for watching and giving me your time. If you gleaned anything from watching this video, I would love if you give me a like and consider subscribing. It would mean a lot. A special thanks to everyone who gave me feedback and positivity towards the first video. I truly appreciate it. It received some excellent attention on the Elder Scrolls Online subreddit and has since been featured on the wiki.esoui.com front page as a tutorial resource. Making these is an extremely time-consuming process as I develop these new features, write the script, record myself re-adding the new features to the code, record this voiceover, and then I have to edit it. It's not easy, but you guys make it rewarding. I hope to see you in-game. Until next time, this is Matt, signing off.